The topic of differentiation is under calculus. Okay, when we talk about calculus, we have what we call the differential calculus, and we also have what we call the integral calculus. Okay, now so what we're going to measure on today is differential calculus, and the process is differentiation. So we're going to talk about what differentiation means, and also the techniques that is involved in differentiations. Okay, all right. So when we talk about differentiation, we talk about the rate of change of a variable. Okay, um, that is how a variable, which we call the dependent variable, increases along with another variable, which is called the independent variable. Okay, for instance, when we have a function, let's say we have a function y, and the function is equal to f of x. We have a function like this. y y is called the dependent variable. Y is called dependent. Okay, x is called independent. Okay, so this is what we call the dependent variable, and what we have here is the independent variable. Now, this guy is dependent because we cannot really choose its value freely. Okay, we can't choose the value of this guy freely. Okay, but this one is independent. We can choose any value for this guy. Okay, we can choose the value for x freely, but we cannot choose the value for y freely because this is dependent and this is independent. Now, when we are asked to differentiate, when we're asked to differentiate, we are asked to find, for instance, find the derivative of the function y. We can write it this way. We can say this means look for the y over dx. Okay. We could also write it this way. We could say this means look for y prime. Okay. Then we could also write it this way. We could say this is look for f of x prime. Okay. Now, this and this, they all imply one thing. They imply the derivative of the function. Okay. Now, don't forget that this will be called the first derivative. First derivative. Okay. Because there are times when we are going to be asked to look for the second derivative. Now, how about second derivative? Now, to write the second derivative, I'm going to write in terms of what the y and the x is going to be the squared y divided by the x squared. Y for this pattern, we'll write it this way: y prime prime. Okay. While for this pattern, we write it this way: f prime prime of x. Now, what they all imply is second derivative. Second derivative. Now, if I understand what I've written here, then it means we will go to the next step, which is the rules of differentiation. All right. First rule that we'll talk about is what we call the power rule. Okay. The power rule. The power rule. And what does the power rule tell us? It tells us that if we have that y is equal to x to the power of n, okay, and we want to look for the derivative, we want to find the derivative, what do we do here? The derivative, the y over dx is going to be bring down the power, okay? This power comes down, power comes down backwards, all right? Now, when the power comes down backwards, we have n. Then write what we have again. Write this guy again. We have x. Then we're going to remove 1 from the power. Subtract 1 from the power. It becomes n minus 1. Okay? This is the power rule. Now, this power rule can be applied for different powers. Negative powers, positive powers, fractional powers. Even when the fractional power is still negative, the power rule is still very, very useful. Now, let me give an instance. Let's say, for instance, I have that y is equal to x to the power of 7, and we're asked to look for the y over the x. Now, let's apply this power rule as easy as it appears. This becomes the y over the x is equal to 7x. See that 7 came down, right? Then write it again, 7, then remove 1 from the power, okay? This will now equal 7x raised to power 6. But this is just the power rule. In the same way, if we have that, in the same way, if we have that the power was a fractional power, let's say we have y is equal to square root of x. Okay, for instance, square root of x. Don't forget that square root of x can be written as x to the power of half. Okay, so we can still apply the power rule. How do we apply power rule here? We can say for therefore y divided by dx will become, the power comes down as usual, 1 over 2. Then write what we have again, x. Then we can remove 1 from the power. You see, we bring down the power, write it again, remove 1 from the power, okay? So we have 1 over 2 minus 1. Now we know that this gives us 1 over 2 x to the power of half minus 1 gives us negative half. So we have negative half. In indices, I can write this again as 1 over 2, okay, times 1 divided by, in indices, when this comes down, it becomes x to the power of half. Okay, so we treated this negative sign by rule of indices. So when we write 1 divided by, the negative sign will now disappear. In the same way, we can still move upwards. Okay, when we move upwards, the negative sign comes back. We move downwards, negative sign disappears. So this seems to be saying 1 times 1 gives us 1, then 2 times it gives us 2. X raised to the power half is still root x. Okay, so you can see that when the power is still a negative fraction, we still apply the same process and we get the same answer. All right. Now, what if I have a constant attached to the I have a multiple, a constant. Let's say, for instance, I have something like this: y is equal to a x to the power of n. Okay. Now, a here is a constant. A could be 2, could be 3, could be any number. All right. It could be negative number. It could be a positive number. Okay. Now, we can still apply the same power rule. How? We do the same thing. The power still comes down. So the y over dx here is going to be equal to, when n comes and becomes n times a, na, then x raised to power, do the same thing, n minus 1. All right. So you can see that what we did here, the n came down to multiply a. So if I have a case like this, let's say for instance, I have that y is equal to 4x raised to power minus 2, for instance. And I'm asked to look for the y over dx. I'm asked to find the y divided by dx. What happens? Now, we don't do anything different. What happens? The same power rule, the power comes down, okay? When the power comes down, we're going to be having minus 2, negative 2 times 4 gives us, we have negative 2 times 4x minus 2. Then we remove 1 from the power as usual. We have minus 1. Okay? So the y over dx therefore gives us minus 2 times 4 gives us negative 8. Okay? Negative 8 x raised to power negative 3. Now, in your exam, you could see that this answer was written in this form: negative 8 divided by x to the power of 3. It is still correct. Remember, it's just the application of the law of indices. All right. Okay, then the next rule is called the sum rule. Okay, we'll talk about the sum rule here. The next rule is called the sum rule. All right. What does the sum rule tell us? It tells us that if I have, for instance, I have y, and y is equal to f of x plus or minus g of x. What this means is I have that f of x, okay, y is a combination of two functions. It could be, the functions could be adding, the functions could be subtracting, but it's a combination. What do we do? It's the same thing. What we do here is to find the y over dx. The y over dx would mean that we are going to find the derivative of this function. That will be f prime of x. Then if it's a plus sign or a minus sign, nothing spoils. Okay, we do the same thing. We look for the derivative of this guy. That will be g prime of x. Remember we said that f prime of x means differentiate the function f of x, and g prime of x means differentiate the function g of x. Okay, we're going to have an example. For instance, let's say for instance we have an example. We have y is equal to, let's say we have that y is equal to 3x squared minus 4x minus 3. Okay, now let's say we have some function like this, which is most likely something like this. F of x is this guy, g of x is this guy. Okay, now what we have here is a negative sign. It could be a positive sign. Okay, what we'll do the same thing to look for the derivative. To look for the derivative here, what we'll do is differentiate this function, find the derivative of a function. We have done this already. 2 comes down, 2 times 3 is 6. That is 6. Write this again, x. Remove 1 from the power, 2 minus 1. For this guy, this becomes negative 4 multiplied by negative 3. Then write what you have again, x. Remove 1 from the power, you have minus 3 minus 1. Alright? So at this point, what we have here becomes dy over dx is equal to 6x raised to power 1. That will be 1 here. Negative 4 times negative 3 gives us positive 12. Alright? Then write x to the power of negative 4. Okay? So you can see that if you want to remove this one here, there's nothing bad. You can still remove the minus the 1 there. Okay? Because x raised to power 1 is same thing as x. So you could write it this way. You could also finally say this is same thing as saying dy over dx is equal to 6x plus 12 over x to the power of 4. Okay, so this is how we can work with the sum rule. Okay, when we have two functions that sum together. Another technique of differentiation that we have is the product rules. Okay, we have the product rules. Okay, now when do we use product rule? Okay, from product, the word product. I use product rule when I have two functions or two terms that I'm multiplying. Let's say, for instance, I have y is equal to u and v. Okay, now u is a term, could be any function, could be trigonometric, it could be hyperbolic, it could be logarithmic. V can be any function also, could be an exponential function. Okay, however, they are multiplying. That's what you should take note of, that the functions multiply. Now when they multiply, what do we do? This is what we do here. The rule is, for product rule, the y over dx is equal to u, keep u, differentiate v, that will give us the v over dx, plus keep v, differentiate u, that will be du over dx. This is product rule. We keep this guy, we differentiate this guy, plus we keep this guy, we differentiate this guy. That's product rule. All right. Now, let's assume that I have something like this. For instance, I have that y, is equal to x squared, okay, x squared minus 1 multiplied by 4x cubed plus 3. Let's say I have something like this, for instance. Okay. Now take note that anytime we differentiate a constant, okay, anytime we differentiate a constant value, we get 0. Okay, anytime we differentiate a constant value, we're going to get 0. Something like this now. Let's say we look for the derivative of, if we look for the derivative of a constant, the result is 0. Okay, which means if we look for the derivative of something like 4, it gives us 0. In the same way, what if we look for a derivative of something like this? Let's say we look for derivative of x, for instance. What do we do? Apply the same technique here. Technique here simply tells us that this is something as saying we are finding the derivative of x to the power of 1. The power is 1. Take note of that. So definitely the power comes down. Power comes on 1. Write this again, times x. We remove 1 from the power. That is 1 minus 1. So this gives us x raised to power 0. And in indices, anything raised to power 0 is 1. So the answer is 1 from here. All right. Now, what this means is, if, for instance, the next time I have to, let's say I have y is equal to 10x, for instance, and I want to look for the y over dx, for instance, what it tells me here is, if I apply the same thing here, if I differentiate x, I'm going to get 1. Remember, we'll be left with 10. So if I differentiate 10x, I'm going to be having 10. Because anytime we differentiate x, we get 1. So if I differentiate x from here, I'll get 1. Then the 10 is attached to the x. Don't forget that what we just do here is also differentiate x, we get 1. And that is it. So it means if I differentiate 10x, I'll get 10. If I differentiate 20x, I'll get 20. If I differentiate 30x, I'll get 30. If I differentiate 100x, I'm still going to get what now? 100x. I'll get 100 rather. Okay? So this is it. So now if we take our minds back to, what we have here, the question that we have here. Okay, we want to apply product rule here. So what do? We want to apply product through the y over the x. What is equal to? Remember that we said we're keeping this first guy here. So we're keeping this guy. We keep this guy. So when I keep this guy, I'm going to be having x squared minus 1. Then multiplied by differentiate the other guy. If we differentiate this other guy here, differentiate 4x cubed, we'll have 12x squared. So this gives us 12x squared. If we differentiate 3, from what I explained, 3 differentiate 3, you get 0. So we have plus 0, close the bracket. Remember that we do plus again, plus, keep v. You know we differentiated v before, now we're keeping v. Okay, so when we keep v is 4x cubed plus 3. Now we're going to differentiate x squared minus 1. We're going to get, differentiate x squared, we'll get 2x. Differentiate 1, we'll get 0. So what we have here is 2x plus 0. Now once we're able to do this, we are now at this point where we have x squared minus 1 into 12x squared plus 4x cubed plus 3 into 2x. We have this. What should be the next step? Simplify the expression that you have. Simplify it. So if I want to simplify it, this is what I have. 12x squared times x squared will give us 12x to the power of 4. Okay. 12x squared times negative 1 gives us negative 12x squared. We're done with this guy. So we'll go over here. 2x times 4x cubed is going to give us 8 plus 8x to the power of 4. Okay. Then 2x times 3 is going to give us 6x. So what we do here, just add like terms. If they're like terms, you add them because 12x for this here, and these are like terms. So we'll bring them together. Okay. When we bring them together, what do we have? We have 12 plus 8 is 12 plus 8 gives us 20. So we have 20x to the power of 4. This follows 12x squared. Then the last of them is 6x. Okay. So remember that when you apply product through, remember that you have to simplify the term that you get after applying the rule. You have to simplify it. You can't just leave your answer like this. You have to simplify it so that it makes more sense mathematically. Okay. All right. Let's say we have a question here on product rules that tells us that find the derivative of x to the power of negative 4 minus x to the power of 4 into 2x squared plus 3x. Now let's say we want to solve this question here. We're going to apply product rules, okay? Because remember that I know that the question is product rules if I have two terms that are multiplying. Okay, remember that these two terms could be of different functions. They could be of the same functions, okay? But let's go with the law. The rule tells us that the derivative is what is asked. Find the derivative is what is asked, all right? So what becomes the derivative applying product rule? What do? We keep this. So let's keep this guy. X minus 4 minus x4. We keep this. And we differentiate what we have here. Okay. So differentiating here, we'll have differentiate 2x squared, we'll have 4x. Differentiating 3x, we're going to get 3. We close it. Plus, now remember, we kept this before. So we're going to differentiate it now. Okay. Why we differentiated this before, but we are keeping it now. So we're going to differentiate this now. Or we're keeping this time around. 2 plus 3x, 2x squared plus 3x. We are keeping this. We are differentiating this. So if I differentiate what we have here, differentiate x to the power of negative 4, we're going to have negative 4x to the power of negative 5. All right. Then if we differentiate x to the power of 4, we're going to have 4x to the power of 3. Okay. Now when we get to this point, we have to simplify what we have. Okay. We have, so let's expand what we have here. We'll get to this point. When we get to this point, what we need to do is to expand. All right. So let's expand. For expand, this times this gives us 4x minus 3. This times this gives us plus 3x negative 4. We're done with using this to multiply. Go down here. This times this will give us negative 4x to the power of 5. Then this times this gives us negative 3x to the power of 4. We are done with expanding this side. So let's go down to the side here. Plus, if we multiply 2x squared times this gives us negative 8x to the power of negative 3. 2x squared times this will give us negative 8x to the power of 5. We're done using this to multiply both of them. So you use 3x now. 3x times this gives us negative 12x to the power of negative 4. Again, 3x times this gives us negative 12x to the power of 4. All right. So when we get to this point, next thing we'll do, we'll bring the like terms together. So what are the like terms we have here? This is a like term. This here and this here are like terms. So let's add those two together. What do we have? Negative 4, negative 8 gives us negative 12x to the power of 5. Okay. Then we're done with power of 5. Let's talk about the power of 4. This guy and this guy has the power of 4. So let's work with them. Minus 3 minus 12 gives us minus 15x to the power of 4. Then again we have the power of negative 3. Okay. So now to not make mistakes, so I don't make mistake, those ones you've worked with, you can work with this. We've worked with power of 5. So power of 5 I've worked with it. Then I've worked with power of 4. So power of 4 I've worked with power of 4. So I can come down to power of negative 3. Okay, power of negative we have 4x negative 3 minus 8x negative. So what we have, if I combine these two here, I'm going to be having negative 4x negative 3. Okay, so I've worked with the negative power of negative 3. Then now the next part to work with is power of negative 4. So we have positive 3x negative 4, negative 12x negative 4. So if I combine both of them, I'm going to be having negative 9x to the power of negative 4. Okay, so I've worked with the last power here. So if you check, I worked with everything. All right. Now, at this point, I can decide to factorize the negative sign here. If I bring out negative sign, we'll be having 12x to the power of 5, okay, plus 15x to the power of 4, plus 4x to the power of negative 3, plus 9x to the power of negative 4, okay. So you can leave your answer this way, or you can leave your answer like this. It is still very correct, all right. But here is the quotient rule, okay. Quotient rule. Now, quotient rule is a technique in differentiation. But when do I apply quotient rule? I'm going to apply quotient rule when I have a function divided by another function, okay. Don't forget that it has to be a function divided by another function, all right. Now, example, we can have a term. Let's say we have y is equal to sine x over exponential x. Now I can see this is a function, trigonometric function, divided by an exponential function. Such differentiation question will require your quotient rules. Okay. Now what does quotient rule tell you? It tells you that if I have something like this, then the derivative is going to be keep the bottom, differentiate the top, okay, minus keep the top, differentiate the bottom, divided by square the bottom. So I'm going to square bottom, which is bottom squared. Now, for short, you could do it this way, that if I have something like this, then the derivative is bottom differentiate the top, that is bottom the top, minus top differentiate the bottom, divided by square bottom. So we have bottom squared. Okay. divided by square bottom, this bottom squared. All right. Now, let's say we have a question like this, for instance. We have a question like this, for instance, that tells us that find the derivative of the function x to the power of, okay, minus 2 over x plus 2. Okay, let's say we have something like this. All right. Okay, let's say x squared. Let's say x squared plus 2. Okay, we have a question like this, and the question is that we should find y prime, which means we should find the derivative of what we have here. Now, what do we do? Don't forget that we are still applying quotient rules here. But this time around, what do we have? The y over the x therefore becomes, what is our bottom? Bottom is this guy. So drop bottom, bottom, differentiate top. What do we have? If I differentiate the top, I'm going to be having 3x squared. Because if I differentiate this, I'll get this. If I differentiate minus 2, I'll get 0. Then minus, you know, keep bottom, differentiate top, minus keep top, differentiate bottom. So we are keeping top now. Okay, then we have to differentiate bottom. And when we do that, we're going to be having 2x divided by square bottom. So when I square bottom, I'll be having x squared plus 2, then you square it. Okay, so we have actually done this step here. The next thing we have to do is to simplify what we have. Okay, let's simplify what we have. Now, how do we simplify what we have here? Watch what we do here. Expand. You can expand. 3x squared times x squared gives us 3x to the power of 4. 3x squared times 2 gives us 6x squared. Now, because of this negative sign, you put the negative sign, put a big bracket, okay? 2x times x cubed gives us 2x to the power of 4, okay? 2x times 2 gives us negative 4x, okay? Now, you don't need to, you can just, when you're solving questions on quotient rule, just leave the denominator like that. Don't expand it, leave it that way. X squared plus 2 all squared. Okay. So that if there is a need to, have common, if there are common terms at the top and at the bottom, they can easily cancel out. All right. So open bracket again, we have 3x to the power of 4 plus 6x squared. Okay. By open bracket, I'll be having negative 2x to the power of 4. Okay. Positive 4x. Okay. Divided by x squared plus 2 all squared. Now, if you check the top barrel, you can see that we still have to arrange the top, and we have, if I combine these two here, we're going to be having x to the power of 4. So my dy over dx therefore becomes x to the power of 4. Okay, because 3x power of 4 minus 2x power of 4 give x to the power of 4. Then plus 6x squared. Okay, plus 6x squared plus 4 x divided by what we have here, x squared plus 2 whole squared. This is going to be the final result of our differentiation on quotient rule rather, that tells you that if y is equal to sine 2x divided by exponential 4x, okay, we should find y prime, which means, you know what y prime means. We should find the derivative of the function here. Okay, now when we have something like this, we can still apply quotient rule. And what do we do here? Remember, the rule is keep the bottom. Okay, so we keep bottom e to 4x, differentiate top. Now remember that, how do we differentiate something like this when we have, let's say for instance, we have sine ax. Remember that for us to differentiate sine ax, differentiate what the sine is carrying. Okay, that's ax. Differentiate ax, you get a. Bring a to the back, so we have a multiplied by. If you differentiate sine, you're going to get cos. So just write it becomes cos ax. All right, so we're doing that here. Okay, the first thing we do, differentiate what sine is carrying, that's 2x. The result is 2. Take it to the back, so it becomes 2 dot differentiate sine, you get cos. Write everything, you have cos 2x. Now we have kept the bottom, differentiated the top. Now don't forget minus we have to keep the top this time around. Keep the top. Okay, you have this. Then differentiate e to the power of 4x. Now don't forget that if we have exponential to a power and I want to find the derivative of this exponential, first thing I will do is I'm going to differentiate what the exponential is carrying and take the result to the back. Now, if I differentiate what exponential carrying ax, I'll get a. I'm taking a to the back. So we have a exponential ax. So when we write through this, bring it down, differentiate ax, get a, take it down. Then if you differentiate exponential function, you get the exponential function. So you just repeat it there. If we do the same thing here, what do we have? We're going to have that if you differentiate e to the power of 4x, you're going to get 4 comes down, 4, then e to the power of 4x, write it back again, write this back again. Okay, divided by square bottom. So this gives us e to the power of 4x all squared. Okay. Now, from my observation, okay, I'm seeing that exponential 4x is common. So let's bring it out. Exponential 4x is common. Open bracket. What is left here? 2 cos 2x. Okay. What is left here? Minus 4 sine 2x. Okay. Now, divided by exponential 4x to the power of 2. Now, with these two are common terms, so I can actually strike out one exponential 4x here, and I'm going to be left with, okay, the final answer, the y over dx, is equal to 2 cos 2x minus 4 sine 2x divided by exponential 4x. Okay, so this is the final answer. All right. Now, the next technique we're going to apply here, we're going to learn here is chain rule. Okay, chain rule is the next technique we're doing now. Chain rule. Now, what does chain rule state? It tells us that dy over dx is equal to dy over du multiplied by du over dx. Okay, this is the rule. This is chain rule. Y is equal to, okay, dy over dx is equal to dy over du times du over dx. Now, if you check very well, you can see that if we do a little mathematics here, this expression here is still the same as this. Okay. Now, when do I know that I have to apply chain rule? When do I know that I have to apply chain rule? When a function is inside another function. Okay, let me give you an instance now. Let's say, for instance, I have something like this: y is equal to x plus 2 to the power of 4. Now, you can see that, look at, we have this term enclosed in the power of 4. Okay, when I see something like this, or I see something like this, y is equal to sine 10x, or sine into 10x squared minus 3. Okay, now you can see that I have a polynomial function inside a trigonometric function. Okay, so anytime I have a function inside another function, just know that I can easily apply, just know that I can easily apply chain rule. Okay. Now, what is chain rule? Let's say I want to apply chain rule in this question. What do we do here? Look at what we do. First thing we say, you see that thing that is inside, that term inside, call it u. Let u be equal to x plus 2. When you do this, next step is to differentiate. So what becomes du over dx? Okay, that gives us 1 from what we see, because if we differentiate x, we get 1, differentiate 2, we get 0. Okay. Next thing is, write what you have again. What is now y? Since you have called u x plus 2, what is y in terms of u? Y in terms of u will now be y is equal to u to the power of 4. Now, next thing you do, differentiate this. What is the y over the u? That is, what is the derivative of y with respect to u? What are you going to get? Apply our power rule. We're going to be having 4u3. Now, since we have gotten the y over the u over dx and the y over du, we can apply chain rule that tells us that the y over dx is dy over du, which is 4u cubed, times du over dx, which we have gotten as 1 times 1. Replacing what we have, this gives us 4 u we said in the question is what we called u x plus 2, so it becomes 4 into x plus 2, okay, to the power of what? 3. This is the answer. Okay. Now there's a technique I will show you right currently. I'll show you a technique, okay, that tells you about when it involves when you want to apply chain rule when there's a power. This is a quick technique to use, okay. Just remember, for instance, we have y is equal to a function of x to the power of n. All right, and I want to find the derivative using chain rule. This is a short technique to follow. I can just easily say the y over dx is equal to bring the power down n. Okay, bring the power down. That's the first step. Differentiate what's inside f prime of x. No, f prime means I found the derivative. Then write what you have again. F of x, subtract 1 from the power n minus 1. I want to repeat this step again. Bring the power down, differentiate what is inside, write it again, remove 1 from the power. Okay? So let's assume I wanted to solve this same question now using this technique. What would I have done? Watch me. The question is y is equal to x plus 2 to the power of 4. So let's follow this step now. Bring power down, the y over dx. Remember? Bring power down, that's 4. Find the derivative of what is inside. What's inside? X plus 2. Find the derivative, you get what now? 1. Write what you have again. Remove 1 from the power. 4 minus 1 is 3. So what do we have here? We are having 4 into x plus 2 to the power of what now? 3. Now you can see that, look at the solution here. We apply here. Look at the solution here and look at the solution here. With this technique, you can just easily do this question in just a single line. You got the question. It's very easy.